Example 4. Solve the quadratic equation. 2x plus 1 brackets squared is equal to 36. Now, this equation here on the left hand side, it's already factorized. So you don't need to factorize any further. Don't try to expand, because expansion is the opposite of factorization. That means that the right hand side is already factorized. So what we do, we are going to first look for ways of removing the square here, and then we solve to find the value of x. Now, when I take the square root both sides of the equation, so this is square root that side and square root that side. Why am I taking the square root? I want to just kill the square there on this other bracket. So what I do on the left hand side, I also do it on the right hand side. So the square is going to cancel away. Then here I'll be having 2x plus 1 is equal to plus or minus 6. Whenever I take the square root, we shall be having two values there. Now I'm going to take that side slowly. Then thereafter I'll be having 2x is equal to something. Then I divide both sides by 2. So 2x is equal to plus or minus 6. This one here minus 1. This equation, we have two of them in there. The first one is 2x is equal to positive 6 minus 1. Another one is 2x is equal to negative 6 minus 1. So these are the two equations that we have. They came from the positive, either positive or the negative. So now, coming back here, the other side, when I simplify, I'm having there a 5. Then I divide both sides by 2 to get the value of the variable as 5 all over 2. Here, when I simplify the other side, I'm having 2x is equal to negative 7. Then dividing both sides by a 2, I have the x as negative 7 all over a 2. Example 5. Solve the quadratic equation. 6x squared minus x minus 2 is equal to a 0. Now, this equation has a constant there on the x squared. So when factorizing, that is identifying the sum and the product. We say for the product, we get this and we multiply it by the whole of that to get the product. The sum is equal to negative 1 because that's the coefficient of the linear term. Then the product is equal to 6 times negative 2 to get negative 12 there. So I look for two factors there that can give me the sum of negative 1 and then the product of negative 12. So those factors, they are negative 4 and positive 3. So I pick them, come substitute them here. That is 6x squared minus 4x plus 3x minus 2 is equal to 0. Now, make sure that you don't substitute the negative 12 in here. Some students have a tendency of making such a mistake. Please follow the equation which was given. The sum and the product here, they just set a pass to generate the factors there, which we substitute for the sum. Now, the story goes the same, factorizing two terms here and those two there. So here, you can see that the 2x is common. So if you remove it there, 6x squared divided by 2x, what will I be left with? 1x is already there, and then here a 3 is also there. So here we are left with 3x, then minus 4x divided by 2x, here the x goes 4 divided by 2, you have a 2, so we shall be left with a 2 there. Then factorizing these two terms, you can see that the only factor there is going to be a 1. So I pull out a 1 into the 3x minus 2 is equal to a 0. Then now I'm going to factorize further because that bracket is still the same. I have two terms now. When I remove that bracket, here I'll be left with 2x. Then there I'll be left with a positive 1. Then into 3x minus 2 is equal to a 0. So either 2x plus 1 is equal to 0, or 3x minus 2 is equal to a 0. Taking 1 the other side, this is going to be 2x is equal to negative 1. Dividing both sides by 2, we shall be getting the value of x as negative 1 all over a 2 there. Then here, taking the 2 the other side, it's going to become a positive. This side we have 3x, and dividing 3x both sides, we shall end up having the value of x as 2 all over 3. Example 6. Find the value of m if 233 base m is equal to 68 base 10. Here, remember when we are talking about the numerical concepts, under the number bases, we used to expand both sides. So this other side, we are not going to expand because it is already in base 10. The reason of expansion is to have both numbers to be in the same base, that is base 10. Then we can find or work out and find the value of the base. Expanding the left hand side, we said we first give powers starting from the right, that is 0, 1, 2, then 2 times m raised to that power there, plus 3 times m raised to that power there, then plus 3 times m raised to that power is equal to 68 there. So this one here becomes 2m squared plus 3m, then plus 3 is equal to 68. This one becomes a quadratic equation because the power of the variable there is raised to 2. Then on the right hand side there is still a number there, so we take it to the right hand side. So this becomes 3 minus the 38. When we subtract there, we have minus 65 is equal to a 0. Then now we identify the sum as positive 3, product as 2 times negative 65 will be equal to negative 130. So the factors there, I have 13 and then 10. So I need to manipulate them to suit these two here. When I make 10 the negative there, when I add them, I'll be having positive 3. When I multiply them, I'll be having negative 130. Students make a mistake, that person can get them there and then ends up negating this one. But when you add here, you'll be having a negative 3 there and then a multiplication of the negative 130. That one is wrong because these factors you have here should suit both the conditions, the sum and the product. Substituting the factors there, 2m squared plus 13m minus 10m minus 65 is equal to 0. So here the first two m is common, so when I pull out the m, here I'll be left with 2m, then plus 13. Then these two here, what is common there is the 5 and negative 1 also. So when I pull out the negative 5, there I'll be left with 2m. Then here I'll be left with positive 13, and that one is equal to a 0. When you reopen, you will go back there. Even here, when you reopen, you go back there. That means that you are on a right track. Then that is the same as that. We need to factorize further. So this is m minus 5 into 2m plus 13 is equal to 0. Either m minus 5 is equal to 0 to get the value of m as 5, or 2m plus 13 is equal to 0. Taking 13 the other side, this is 2m is equal to negative 13. Dividing both sides by 2, I end up getting m as a negative 13 all over a 2. Now, solving the quadratic equation, this one here, these ones are the two answers. But for this particular question, they said you find the value of m if this is equal to that. Now, you cannot have a negative base. So we are going to eliminate this answer of ours because the question was not to solve the quadratic equation. Therefore, the final answer of m is a 5. Example 7. Factorize the expression 3n squared minus 10 plus 3. Then hence find the values of n when that expression is equal to 0. Now this one here has two questions in one. The first one, factorize the expression alone. Then the next one, solve this equation here. So factorizing the expression, we said you need to identify the sum and the product. Sum is equal to negative 10. Product is equal to 3 times 3 there. You get positive 9. The factors there, they become negative 9, negative 1. When I add them, I have negative 10. When I multiply, I have a 9 there. So I substitute them here where there is the sum. This one is going to be equal to the 3n squared minus 9n, then minus n plus 3. Then factorizing two terms. Factorizing there, what is common is the 3n. So 3n squared divided by the 3n, that one you are left with n. So there we are left with n. Then 9n divided by 3n, that one shall be left with a 3 minus a 3. Then when we come to these two terms, negative 1 is common, so that the n is positive and the 3 is a negative, and that is the same bracket here. Factorizing further, we are having 3n minus 1 into n minus 3. I'm now here just speeded because we did this so many times. That is factorizing using the expressions alone, then also solving quadratic equations. We have been also using the same thing. So the whole of 3n squared minus 10n plus 3 is now 3n minus 1 into n minus 3. Mostly these ones we can call them factors. So now I'm going to solve this equation is equal to 0. In other words, I'm going to find the values of n there. It is quadratic, so I should get two answers there. But now the question said hence Hence, we are meaning that you use what you have got previously to help you get the answers on that question next. So the left hand side has been condensed to the whole of that. Now I'm going to substitute this right hand side for 3n minus 1 into n minus 3 is equal to a 0. So I've used, because this expression was factorized to get that, now I've got that factorized expression. Now I've equated it to 0. Then either one of them or both of them is equal to 0. So either n minus 1 is equal to 0 or n minus 3 is equal to a 0. Taking negative 3 that side, n is equal to positive 3. Taking 1 that side there, we shall be having 3n is equal to positive 1. Divide this side by 3 and that side by 3. N is going to be equal to 1 all over a 3. So we have that and also that value of n. So as we are winding up our lesson today, we have said that the quadratic equation is always in that form there. The quadratic term, linear term, and the constant term should be equal to 0. We can have a scenario where any of these two are missing in the equation. For example, this equation here, x squared plus 4x is equal to 0. The constant term is missing. So there, you don't need to go into steps of identifying the sum and the product. Since there are two terms there, you just need to factorize the left-hand side. That is, x is common in those two terms there. So when I pull out the x, I'll be left with x plus 4 inside the bracket. And this one here is equal to a 0. So either x is equal to 0 or x plus 4 is equal to a 0 there. And here you end up getting the value of x as negative 4 there, and x is equal to a 0. This equation here is missing a linear term. So here you just need to take the constant term, the other side of the equation, so as to give you x squared is equal to 9. Then you take square root both sides, and then you end up getting the value of x as plus or minus 3 right there.